There comes a point where the warmth of the sun no longer feels familiar. Far beyond the last planet, beyond the frozen worlds that circle in darkness, there exists a place where sunlight is little more than a distant memory. The solar system grows thin there. The comforting influence of the sun begins to fade, and the endless black of the galaxy quietly takes over. Human technology was never expected to survive in such a place. Yet one small spacecraft still drifts through that unimaginable darkness. It is still awake. It is still listening. And after traveling farther than anything humanity has ever built, it continues to whisper back across billions of kilometers of empty space. Its name is Voyager 1. When Voyager 1 left Earth in September 1977, no one imagined this would become its story. Engineers had built it for a simple assignment: visit Jupiter, continue to Saturn, collect as much scientific information as possible, and then allow its mission to end naturally. It was expected to serve for only a few years. Instead, those years became decades. Before we continue following Voyager's incredible journey into the unknown, if you enjoy stories that explore the mysteries of space and the universe, please subscribe to the channel. We're working toward our first 1,000 subscribers. Now, back to Voyager's extraordinary mission. The spacecraft passed Jupiter, then Saturn. Then it continued beyond every destination anyone had planned for it. Eventually, it crossed the invisible frontier surrounding the sun itself and entered a region no human-made object had ever reached before. There, in the immense darkness between the stars, Voyager encountered something no one had expected. Not a signal, not a mysterious transmission, but something stranger. A faint, continuous hum. An almost imperceptible vibration flowing through interstellar space itself. Not a sound that human ears could hear. Not a voice. Instead, it was the quiet electrical resonance of the galaxy. Voyager's extraordinary journey had begun with surprisingly ordinary expectations. NASA launched two nearly identical spacecraft, Voyager 1 and Voyager 2, to take advantage of an opportunity that appears only about once every 175 years. During this rare alignment, the giant outer planets line up in such a way that a spacecraft can use each planet's gravity like a slingshot, gaining speed while conserving precious fuel. It was known as the Grand Tour, a chance that no generation before had possessed, and few generations afterward would see again. NASA knew it could not waste such an opportunity. Almost immediately, Voyager 1 began exceeding expectations. Only days after launch, while already millions of kilometers from Earth, the spacecraft turned its cameras backward. Looking home, it captured the first photograph ever taken from deep space that showed Earth and the Moon together. At the time, it seemed like a remarkable image. Years later, it would feel like a prophecy. Voyager was no longer simply studying the solar system. It had become humanity's witness, carrying our curiosity farther than anyone had imagined possible. The crossing into interstellar space changed something fundamental in humanity's understanding of the universe. For decades, scientists had imagined that once the sun's influence faded, space beyond would be calm and nearly empty. Instead, Voyager 1 discovered a very different reality. The protective bubble created by the solar wind, the heliosphere, was not expanding into a silent void. It was standing its ground against an interstellar environment far more structured and far more powerful than anyone had expected. Beyond the sun's frontier, the galaxy was pressing back. But that was only the beginning. Among everything Voyager 1 discovered after crossing the heliopause, one finding stood apart from all the others. It wasn't a photograph of a distant world or the detection of an unfamiliar particle. It was something quieter, and perhaps even stranger. Between 2017 and 2020, the aging spacecraft began detecting a steady signal at roughly 3 kilohertz. It wasn't a sudden burst. It wasn't the aftermath of an explosion. It wasn't a brief flare that appeared and disappeared. It never seemed to stop. A faint, persistent hum surrounded the spacecraft as it drifted through the plasma between the stars. Of course, this was not sound in the way people experience sound on Earth. There was no air for vibrations to travel through and no ears that could hear it. Instead, the signal was a plasma wave, an electromagnetic oscillation moving through the thin, ionized gas that fills interstellar space. Yet hidden inside that quiet vibration was something remarkable. Its frequency revealed the density of the plasma surrounding Voyager 1. For the first time in history, humanity was no longer imagining what existed between the stars. It was measuring that environment directly from within it. As Voyager continued its lonely journey, it was, in a sense, listening to the electrical resonance of the galaxy itself. That realization gives the mission an almost haunting quality. Voyager is not drifting through empty darkness. It is traveling through a real landscape, one sculpted over millions of years by exploding stars, invisible magnetic fields, streams of charged particles, and the vast local bubble of interstellar space that surrounds our solar system. The hum is not a message waiting to be decoded. It is simply the universe existing. It is the quiet electrical whisper of the medium through which our solar system has been moving for millions of years. No human had ever measured that whisper directly. Voyager 1 became the first. Perhaps even more astonishing than what Voyager discovered is the simple fact that it is still capable of discovering anything at all. The spacecraft belongs to another era. Built with 1970s technology, it carries only a tiny amount of memory by modern standards. Every component aboard was designed for a mission expected to last only a few years, not nearly half a century, in the freezing darkness beyond the planets. Yet Voyager refused to follow those expectations. More than 24 billion kilometers from Earth, it continues sending scientific data home using a transmitter whose power is roughly equal to that of a dim household light bulb. By the time those signals finally reach Earth, they are almost unimaginably weak, nearly lost within the background noise of the universe itself. Even so, our instruments still hear them. Keeping Voyager alive, however, has demanded years of careful sacrifice. Engineers at NASA have gradually powered down one instrument after another, shutting off every system that was not absolutely essential. Each decision bought the spacecraft a little more time, another chance to continue exploring a place no human being could ever visit. Then, late in 2023, that fragile balance nearly came to an end. Without warning, Voyager stopped sending usable information. Instead of meaningful telemetry, Earth received only corrupted, meaningless data. A failure inside the spacecraft's flight data system had damaged part of its memory. The challenge seemed almost impossible. Every command sent from Earth required roughly 22.5 hours to reach Voyager. Every reply needed another 22.5 hours to return. A single exchange with the spacecraft consumed nearly 2 full days. Yet the engineers refused to give up. Working with technology designed in the 1970s, they rewrote decades-old software, redirected critical code around the damaged memory, divided complex instructions into smaller pieces that could fit inside the remaining healthy sections, and transmitted the repair across more than 24 billion kilometers of empty space. Then they waited. Nearly 45 hours later, Voyager answered. This time, its telemetry made sense. Against extraordinary odds, the spacecraft had come back to life. It was a resurrection measured not only in time, but also in distance. one of the most remarkable engineering recoveries ever attempted. Because of that success, Voyager continued its journey through interstellar space, still quietly listening to the mysterious plasma hum surrounding it. Yet the spacecraft carries something even more enduring than scientific instruments. Bolted securely to its exterior is the Golden Record, a gold-plated disc containing photographs of Earth, greetings spoken in dozens of languages, music from many cultures, and the natural sounds of our world. The Golden Record carries more than data. Pressed into its gold-plated surface are small pieces of an entire world, images of Earth, greetings spoken in dozens of languages, music from across human civilization, and the sounds that have echoed across our planet for millions of years. Rain falling onto the ground, ocean waves rolling onto a shore, thunder rumbling across the sky, birds singing at dawn, a mother speaking gently to her child, the music of Bach, the genius of Beethoven, the unmistakable rhythm of Chuck Berry. NASA never expected another civilization to discover the record anytime soon. That was never the point. The Golden Record exists because humanity made a simple decision. If something built by human hands was destined to leave the solar system forever, then it should carry proof that we existed, and that we understood the extraordinary meaning of reaching beyond our own world. That decision transformed Voyager 1 into something greater than a spacecraft. It became an emissary. Its journey began as a brief expedition to the outer planets, yet it returned far more than anyone had imagined. Along the way, it revealed active volcanoes on Io, inspired the search for a hidden ocean beneath Europa's frozen crust, uncovered the remarkable chemistry of Titan, mapped the true boundary of the heliosphere, and ultimately detected the quiet resonance of plasma filling interstellar space itself. Then came its greatest crossing. Voyager passed through the invisible membrane separating the Sun's domain from the vast galaxy beyond. Most expected that, after reaching such an unimaginable distance, the spacecraft would eventually fall silent. Instead, it kept speaking. More importantly, it kept listening. Even now, it continues exploring a place no human being will reach for a very, very long time. Perhaps that is why the mysterious hum matters so deeply. It is not merely another scientific measurement collected in deep space. It is evidence that humanity has finally placed one of its instruments inside the galaxy itself and kept it operating long enough to discover what that environment is truly like. Not through imagination, not through mathematical models, not through poetic descriptions, but through direct physical measurement. Voyager 1 is no longer simply traveling away from home. It is teaching us what surrounds home. The signal it continues to detect is not a message in the science fiction sense. There is no hidden language and no cosmic greeting waiting to be translated. Instead, there is something arguably more profound, a steady plasma hum filling interstellar space, the electrical whisper of the medium between the stars, the quiet background voice of a region of the Milky Way that no human-made instrument had ever explored from within. For generations, that place existed only in equations, computer models, and scientific theories. Voyager crossed into it. Then it began telling us what it actually feels like. That is why this mission has become so extraordinary. Voyager 1 was never meant to accomplish any of this. It was designed for a mission lasting only a few years, exploring Jupiter and Saturn before quietly fading into history. Instead, it became humanity's first enduring witness to interstellar space. It transformed our understanding of Jupiter. It reshaped what we knew about Saturn. It revealed new possibilities on Titan and Europa. It redefined the heliosphere. And now it continues teaching us about the plasma environment that surrounds our entire solar system within the galaxy itself. Even more astonishing is how it continues to do so. Armed with technology designed in the 1970s, powered by an energy source that grows weaker every year, and transmitting signals so faint they barely reach Earth at all, Voyager still listens. It still reports. It still hears what no human being has ever heard before. Yet every story has its final chapter. One day, Voyager's power will finally become too weak. Its instruments will shut down. Its transmitter will fall silent. For the first time since 1977, Earth will no longer hear its distant voice. But silence will not mean the journey has ended. Long after its final transmission fades into history, Voyager 1 will continue moving outward. The golden record will remain attached to its side, carrying humanity's greetings through the darkness, traveling farther from the sun, farther from Earth, and deeper into the Milky Way than anything our civilization has ever created. It will continue drifting through the same quiet plasma hum that it became the first spacecraft to detect. A small machine built by one young civilization, forever crossing the darkness between the stars, listening to the universe for as long as it possibly can. And perhaps that is Voyager 1's greatest legacy. It did not simply leave the solar system. It changed the way humanity understands its place within the galaxy. The farther Voyager travels, the stranger, the larger, and the more beautiful the universe continues to become. The spacecraft passed Jupiter, then Saturn. With every encounter, Voyager 1 moved farther from the world that had created it. The blue planet that launched it was shrinking into a distant point of light, while the vastness of the outer solar system opened before it. But distance alone was not what made Voyager remarkable. What made it extraordinary was what it discovered along the way. In 1979, Voyager arrived at Jupiter, the giant king of planets. Scientists expected spectacular views, but what they received was something far more important. The spacecraft revealed details that transformed humanity's understanding of the Jovian system. It confirmed that the Great Red Spot was not merely a colorful feature decorating Jupiter's atmosphere. It was a colossal storm, larger than Earth itself, raging with incredible power and persisting for centuries. Then came another surprise. Voyager discovered Jupiter's faint ring system, something no one had expected to find so clearly. Around the giant planet orbited worlds that seemed almost like miniature solar systems of their own. New moons appeared in the data, each carrying its own mysteries. And then Voyager looked at Io. What it saw stunned scientists around the world. Towering plumes of material were rising above the moon's surface. Volcanoes were erupting in real time. Until that moment, Earth had been the only known world where active volcanism had been observed. Suddenly, that assumption vanished. The solar system had become a far more dynamic place than anyone had imagined. Yet Jupiter was only the beginning. Among its many moons was another world that seemed quieter at first glance. Europa appeared smooth and bright, covered in a shell of fractured ice. Its surface resembled broken sea ice drifting across a frozen ocean. The images raised a question that would echo through planetary science for decades. What if that ice was hiding something beneath it? Scientists began to suspect that an immense liquid ocean might exist under Europa's frozen crust. An ocean protected from the harshness of space, hidden from view, and possibly containing conditions suitable for life. Voyager had not found life, but it had revealed a place where life might one day be found. That possibility alone changed everything. The mission that had begun as a planetary survey was becoming something larger. Every image seemed to open another door. Every discovery created new questions. By the time Voyager reached Saturn, expectations were already high. Even so, Saturn managed to exceed them. As the spacecraft approached, the planet's famous rings revealed themselves in astonishing detail. What had once appeared from Earth as a handful of broad bands turned out to be an intricate structure made of thousands upon thousands of delicate ringlets. Some were braided together, others were sculpted by the gravitational influence of nearby moons. The entire system looked less like a set of rings, and more like a living, changing work of celestial art. Then Voyager turned its attention toward Saturn's largest moon, Titan. For centuries, Titan had remained hidden beneath a thick orange haze. No telescope on Earth had been able to see clearly through its atmosphere. Scientists knew almost nothing about the surface concealed below. Voyager changed that. The spacecraft revealed a world unlike any other in the solar system. Titan possessed a dense atmosphere rich in complex chemistry. Temperatures were so low that methane behaved much like water does on Earth. Clouds could form, rain could fall, rivers and lakes could exist. It was a world that felt strangely familiar and completely alien at the same time. The farther Voyager traveled, the more the solar system seemed filled with possibilities. Worlds once thought to be simple points of light were revealing oceans, volcanoes, storms, and environments no one had imagined. And with every discovery, Voyager 1 was becoming more than a spacecraft. It was becoming humanity's eyes in places no human being had ever seen before.